In this video, I'd like to talk about the math question of the day from March 8th, 2023. And we need to solve this rational equation for the variable x. So to solve an equation like this, you do need to have an understanding of algebra, particularly algebra 2, since that is where this is typically taught. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, we can go through this together. Now, assuming that you have attempted the problem, let's start going through this together. And if you do have suggestions for future questions of the day, feel free to leave those as a comment. Now, when solving rational equations, we have our variable x in the denominator. So our first step is to get x out of that denominator. And we can do that by multiplying both sides of the equation by this denominator. And in this case, both of these are the same. If they're different, then we would have to have two different steps. But since each of these denominators are x plus 2, if we multiply each of these terms by x plus 2, they will cancel out for both of these fractional terms. And we would transform this into some equation where now x is in the numerator. It would be some type of polynomial equation. So let's first start, and actually I could scroll back over. We're going to multiply each side of this equation, if I put this in parentheses, by x plus 2, and we'll do the same over here. And then this x plus 2 will just distribute to both of these. Now, when it distributes to the 3, I'll first just write 3 multiplied by x plus 2. But when it distributes to this term, like I mentioned, the x plus 2 in the denominator and the numerator, those will cancel, so that we just get back the numerator here. We get minus x plus 1, but we got to be careful since we are subtracting this entire quantity, so we need to put it in parentheses. Now on the right hand side, the x plus 2's cancel, and we just get back the numerator, which is 11x minus 2. Now from here, we can simplify by using distribution. We can distribute the negative 1 there. We get 3x plus 6 minus x minus 1. This is equal to 11x minus 2. And we can combine like terms. Those are similar. They are both variable, and these are both constant terms. 3x minus x, that's just 2x. 6 minus 1, that is positive 5. And we just have a linear equation with variables on both sides. So let's make a little bit of room. We can continue working on this. We need to get the variables on the same side, so let's move them to the side with more of that variable to avoid negative numbers. We can subtract 2x on each side. We get 5 is 9x minus 2. And with this two-step equation, we need to isolate the variable terms. So let's cancel out the minus 2 by adding. We add 2 on each side. We get 7 is 9x. And lastly, we can divide everything by 9 to cancel out that multiplication, so that we get x is 7/9. And of course, this is what we think is the answer, but to prove it's the answer, we need to plug it back in. So we think that x is 7/9, but we need to plug it in anywhere we see an x here. And admittedly, this is fairly tedious. So if you want to check this using a calculator, if you know how to do that, then that will certainly be a faster method, since we will be doing a lot of fraction arithmetic. But let's try to do it just to get some practice with those fractions. Again, we are checking. We think that x is this 7/9. We will plug it in anywhere we see an x, so that we get 3 minus 7/9 plus 1, all divided by 7/9 plus 2. This should be equal to 11 multiplied by 7/9 minus 2 divided by 7/9 plus 2. And like I mentioned, we just need to do a lot of fraction arithmetic. First of all, we can rewrite 1 as 9/9, where 2 is 18/9, and we can apply that here. This is 18/9, and this is also 18/9. Now simplifying, what we have 3 minus 7/9 plus 9/9, which would give us 16/9. And in the denominator, we have 7/9 plus 18/9, which would be 25/9. And then let me make more room here. This will be equal to the right-hand side, or it should be equal to. We do 11 times 7, that's 77 over 9, and we're subtracting 18 over 9, so that we get 59 over 9 in the numerator, and the denominator, 7 ninths plus 18 ninths, we already know is 25 ninths. And if we continue working up here, we can notice that these 9s would cancel out. These division by 9 in both the numerator and denominator in both of these fractions. Since you can imagine, we can just multiply top and bottom by 9. That cancels out that fraction. And we do the same here. But by multiplying top and bottom by 9, we're just multiplying by 1, so we're not actually changing anything. So we get 3 minus 16 over 25, and this should be equal to 59 over 25. And giving these a common denominator, this would be 75 over 25 minus 16 over 25. And taking away 16 from 75 would give us 59. So after working through all that fraction arithmetic, we did get back something that made sense, which means we can feel very confident that x is in fact 7 ninths. Though, like I mentioned, if you do have access to some type of graphing calculator, that will allow you to check these by just substituting this in as your variable and then rewriting the equation. That is usually the faster method and will avoid all this fraction arithmetic. But it is good practice to work through these fractions on your own. So it's your choice which one you want to use, but ultimately you should be able to do this by hand.